the number of real values of x such that x, greater integer function of x, fractional function of x are in HP, where the symbol this denotes greatest integer function, flower symbol denotes fractional part of function. We need to find the number of real values of x. Let's see how to solve it. What they given x, comma, greatest integer function of x and fractional part of x are in HP. Let's see how can we find the real values of x. Suppose if we have a, b, c are in HP, that means their reciprocals in AP, isn't it? We know that. So that means 1 over a, 1 over b, 1 over c, these are in AP. If any three numbers are in AP, suppose if we take x, y, z, suppose any three numbers are in AP, the middle term, that means the y, is equal to the arithmetic mean of the other two, isn't it? That means x plus z by 2, that this we can write as 2y, that is equal to x plus z. So like that, if you have any three numbers in AP, we can write this. We have 1 over a, 1 over b, 1 over c. So if these three are in AP, that means we can write this as middle term equal to 1 over b is a middle term. So 1 over b, that is equal to arithmetic mean of the other two. So 1 over a plus 1 over c by 2. If you multiply both sides by 2, then 2 gets cancelled. So we can write this as 2 over b, that is equal to 1 over a plus 1 over c. But in our given question, we have a x, greatest integer function of x, fractional function of x are in HP. So let's write in this form. So x, greatest integer function of x, fractional part function of x are in HP, that means their reciprocals are in AP. If these three numbers are in AP, so we can use an arithmetic mean here. So the middle term is going to be 1 over greatest integer function of x, so that is equal to arithmetic mean of the other two. So that is 1 over x plus 1 over fractional function of x by 2. So if you multiply both sides by 2, then here gets cancelled. So we left 2 over greatest integer function of x, that is equal to 1 over x plus 1 over fractional function of the x. So each and every time this greatest integer function of x, fractional function of x, keep on say like this is difficult, but let us consider the greatest integer function of x as some g and a fractional function of x as some f. So then this equation is going to be 2 over capital G equal to 1 over x plus 1 over capital F. From here we need to find the real values of x. How can you find the real values of x? So if you want to find the real values of x, first you need to recall what the symbol means. So what we have given symbols are greatest integer function and other one is fractional function. So greatest integer function is always less than or equal to x. Let's observe with the example. So if you want to find the greatest integer of 2.7, so it is going to be 2, isn't it? Suppose if you want to find the greatest number of minus 0.3, it is going to be minus 1, isn't it? So that means the greatest integer function always less than or equal to x. So that is a greatest integer function. Now let's recall the fractional function. If you do x minus greatest integer function of x, then we are going to get the fractional part of x. Suppose if we take x as 2.7, fractional part of this 2.7 is equal to, so x, what is x? 2.7 minus what is greatest integer part of 2.7, which is 2. So let's take 2. So that is going to be 0.7. So the fractional part of the 2.7, which is 0.7. So like that you need to find the fractional part of the any given value. By the definition we can write this 0 less than or equal to fractional function of x is less than 1. That means this fractional function of x always lies in between 0 and 1. Sometimes it is not going to be 0 also. So we can write, by the definition we can write this as 0 less than fractional function of x less than 1. So let's come to the point. From these two, how can you find the number of real values of x? That is a question here. So here we have a capital F and here we have a capital G and x. So this capital F, capital G, capital X are in denominators. So definitely this fractional function is not going to be 0 because it is in denominator. If it is 0, then the function is going to be undefined. That's why this capital F is not equal to 0. Similarly, capital G also not equal to 0. The x also not equal to 0. According to the definition, the f lies in between 0 less than this fractional function less than 1. That means the f is lies in between 0 less than f less than 1. That we know that. So this is an x minus greatest integer function. This is the definition of the fractional function, isn't it? So we consider this fractional function of x as capital F. So that is equal to x minus this greatest integer function. We consider this as a capital G. So from here we can write x as f plus g. Let's substitute this as x as f plus g in our this equation. Consider this as 1. So let's take that equation and simplify that. What we have 2 over capital G, that is equal to 1 over x. So just now we found x is nothing but capital G plus f, capital F, plus 1 over capital F. If we take LCM here, f times g plus f, numerator we are going to get f plus g plus f, which gives g plus 2f. On the left hand side we have 2 over g. If you do cross multiply, then it is going to be 2f times g plus f, that is equal to g power 2 plus 2gf. On the left hand side we have 2gf plus 2f power 2. So only this 2gf part sent to the left hand side, then it is going to be minus 2gf, that is equal to g power 2. This plus 2gf minus 2gf gets cancelled, so we left only 2f power 2, that is equal to g power 2. So from here we can say that f equal to or minus g over root 2. By the definition we know that this f is lies in between 0 less than or equal to f less than 1, isn't it? That means here we should take only the positive values, not the negative values. So according by the definition we should take only positive values. So that's why f is going to be only plus g over root 2. By the definition we can write this f function lies in between 0 and 1. So instead of f we can write g over root 2, that is less than 1. If you multiply both sides by root 2, then 0 less than or equal to g less than root 2. So what is the value of root 2? Root 2, the value is 1.414. And we know that this g cannot be 0. If g becomes 0, it is going to be, the function is going to be undefined. That's why you should not take equality here. So just take only 0 less than g less than 1.414. That means, so the only integer choices for the g are minus 1 and 1. So if g is minus 1, then f is going to be minus 1 over root 2. Similarly, if g is plus 1, then f is going to be 1 over root 2. We know that x is g plus f. So if you substitute g as minus 1, then x is going to be minus 1. So if g is minus 1, then f is minus 1 over root 2. That means minus 1 over root 2. So this is one real number. Suppose if you take g as positive 1, then x is going to be, g is positive 1 plus f is 1 over root 2. So this is another real value. So finally we got 2 real values of x. So the answer is 2. That's it. If you like this content, please like, share and subscribe to my channel. Thank you for watching.